Okay, today's section 2.3, quadratic functions. So we've talked about linear functions, which make lines, and now we're going to talk about quadratic functions, which make a picture called a parabola. Their form is ax squared plus bx plus c. It's just like this. And the biggest thing is your a can't be 0. You want it, this x squared is what makes it a quadratic function. It is a polynomial of degree 2. That means that it has an exponent. The highest exponent on the variable is a 2. So let's look at some basic ones. The most basic is just when a is 1 and b and c are 0. So it looks just like this. It's kind of like a U. This point on the bottom of the bowl is a minimum. A quadratic function always has a minimum or a maximum. In this case, it has a minimum, and this is also called the vertex. It's the point where it changes direction. The graph is called a parabola, as I said, and it is an even function. An even function means that any function value equals the same function value if you inputted a negative x. So f of 1 is going to be the same as f at negative 1. See here? Our f value at 1 is here. At negative 1, our f value is here, same place. Same y value for x and negative x. That makes it an even function. Now, if we have, let's look at f at x equals negative x squared. If we have that one, it looks like this. It's still even, still a parabola, but this time we have a maximum. So this negative sign up here makes it a hill, but if it's positive sign, it's a bowl. So negative sign means a hill, positive sign means a bowl. Now, while this here is our general form, just like with lines, the general form doesn't help us much. So we have a standard working form. Our f of x, let's use a different color. Our f of x equals a times x minus h squared plus k. Make sure you pay attention to those signs. It's x minus h and plus k. Okay, x minus h squared plus k. Now, the reason this is much more helpful is because we have our vertex. We could just pull it right off here. It's h comma k. Whatever we're subtracting here, whatever we're adding here, that gives us our vertex. Remember, that's the top of the hill or the bottom of the bowl. If our a value, this number out front, is positive, then it opens up, it's a bowl. If our a value is negative, it opens down, it's a hill. It also, the number of a, whatever number that is, the value, affects the steepness, how open the parabola is. If a is small, then it's a wide open parabola. If a is large, then it's a narrow opened parabola. We also have what's called the axis of symmetry, which is the part about it being even, and we can pull that right off of here too, x equals h. For example, we looked at this one here, where we have f of x equals x squared. Well, our vertex, well, what's h? We have x minus, well, nothing, so h is 0, and we're not adding anything either, so k is 0. So our vertex is at 0, 0. Our number out front is positive, so it opens up, it's a bowl. And what's our number out front? Well, it's 1. So it's just a basic bowl. It's not real wide, not real skinny. But our axis of symmetry shows us how it's even. If you put a line straight down through the vertex, you get this axis of symmetry. And it should be a mirror image on both sides. Remember, that's what symmetry means. It's a mirror image. So this is our standard working form, and it's very important that you know how to deal with this. And we're going to have to deal with it by completing the square, which hopefully everybody remembers. So let's try an example. If we start out with general form, and remember, we're going to go back and forth between y and f of x because it's the same type thing. So let's say we have this parabola here. Well, we want it to look like a number out front, and then x minus h squared, and then plus k. So we want it to look like this, standard working form. So the first thing we're going to do is factor the coefficient of x squared from the x squared and the x terms. What do I mean by that? Well, there's a coefficient here. Remember, that's the number in front of the variable. And we're going to take it and factor it out. So if we factor this out, we pull it out, we have x squared. Well, what do I have to multiply times 1/2 to get 2? Well, I have to do 4, right? So I have plus 4x. And I just factored it. Let's not do that yet. I just factored it from the x term. Now this extra term here, I'm just going to leave it off on the end for now. Okay, because I want this plus k. All right. So, what do we do next? Well, now we have to complete the square. In this parentheses here. So, remember, completing the square, take the middle number, the x one, divide by 2, and then square it. So 4 divided by 2 is 2. 2 squared is 4. So that's what I'm going to add here on the end, plus 4. Now, for this to stay the same, I can't just add 4. I've got to take it away on the other side. But you have to be careful. What did I add to the equation? I didn't add 4 to the equation. I added 1/2 times 4 to the equation. So what I really did was add 2. So that means I've got to subtract 2 off the end so that where I added 2 here, I subtract 2 here, and I haven't changed the equation at all. All right, and then the last thing you do is factor and simplify. So when you complete the square, remember, you set it up so that the factoring is easy. So now you just take that square root of that, and it should work out. What's x plus 2 times x plus 2? Well, 2 times 2 is 4. 2x plus 2x plus x squared. So I've got this. Make sure you check it and that it actually factors out to be that. If you are having trouble with factoring or completing the square, then you need to come see me because that's an Algebra 2 skill that you should already have. So make sure you know how to do that. So now I've got this neat little equation. So I know that my vertex is at, well, x minus what? What's my h? -2, because x minus -2 would give me this plus sign here. And then plus k, well, what's my k then? My k is -4. My axis of symmetry is going to be x equals my h value. And my a is greater than 0 because it's 1/2, right? So the vertex is a minimum, which means it's a bowl. And it's 1/2, so it's small, so it's going to be kind of a wide bowl. So now I know how to graph this. So how do I graph it? Well, first thing you need to do is graph the vertex. because the vertex gives you that starting point. And then you can use the fact that you have this axis of symmetry to graph it pretty easily. All right, so I graph my vertex. There it is. Now, there's a couple of different ways to graph it. You can just go up to the next value and figure out if you use that x, figure out what the y is. So we could go and plug in -1 here and figure out what y value is. Or you can go a little further over and go over to 0, and that makes it even easier. So if you plug in 0, you can either use this one, your standard working, or your general form. Either way, if you're plugging in 0, it's easier to use the general one. But remember, they're the same equation, just rearranged. They should give you the same exact picture. So we plug in 0, and we get that our y has to be -2. Well, so we went over 2 this way, and we went up 2. Well, that means because it's symmetrical, because it's even, we're going to go over 2 this way and go up 2. So we get our parabola. See how it's a little bit wider than the other one because of that 1/2? Now, that's one way to graph it. Another way to graph it is to use something called the roots or the zeros. Now, what the roots or zeros are is where the y values are 0. That's pretty easy, right? That's why they're called zeros. So the zeros are where y equals 0. So that's where it crosses the x-axis. Now, there's a couple of ways. We set y equal to 0, and then we solve it. We can solve it by factoring. We can solve it by completing the square. And we can solve it by the quadratic formula. Those are our ways to solve that equation. So if we want to know what the zeros are, where do we cross the axis? Here and here. These are the zeros. How do we find those zeros? Well, we can use this here, and instead of having y, set it equal to 0 because that's what the y value is on the x-axis. And you can either factor this or use the quadratic formula, or you can use completing the square, which we've already actually done. So if we set that equal to 0, then we can solve this equation because we've just got one variable now, and we know how to solve this. So when we solve it, we add 4 to both sides. So we get 4 equals 1/2 times x plus 2 squared. Then we can multiply by 2 to get rid of that 1/2. And then we have to take the square root. Now remember, when you take the square root, don't forget your plus and minus sign because there are 2 possibilities. So then we subtract 2 for both sides, and we get our 2 answers. We have x is -2 plus the square root of 8, and we have x is -2 minus the square root of 8. So what this tells us is you couldn't have done this by factoring. You did it by completing the square, or you could have used the quadratic formula. Remember quadratic formula? Opposite b plus or minus square root of b squared minus 4ac all over 2a. I'm sure you guys can come in and sing the song to me tomorrow. Make sure, though, that you know how to solve this. So then what that tells us is this point here is the -2 plus the square root of 8, comma 0. And this one is -2 minus the square root of 8, comma 0. Those are the roots, or the zeros. Now, why does it have 2? Well, it's a quadratic. Every single quadratic has 2 zeros. Now, they may be imaginary, but you have 2 zeros, period. every time with a quadratic. All right, let's try one more. We've got y equals x squared minus 2x minus 8. And I want to find the zeros. Well, we have x squared minus 2x minus 8 equals 0. So what are my choices? Well, I can factor it. I can use a completing the square, or I can use a quadratic formula. Well, you have to decide. And if you're pretty comfortable with factoring, you should be able to look at this and see, well, I can factor this. So there's no point in not factoring it. So we've got x minus 4 times x plus 2 equals 0. So check yourself. So minus 4 times 2 is minus 8. And then we've got minus 4x plus 2x. So that gives me minus 2x. And then I've got x squared. So then for these two things multiplied together to be 0, one of them has to be 0. So your two choices are x minus 4 equals 0 and x plus 2 equals 0. So we've got x equals 4 and x equals negative 2. So that's what the zeros are for that particular quadratic. Now, we didn't do the work to graph it. We haven't found the vertex and those kind of things, but we do know where the zeros are. So that would help us out. So let's try graphing one. What if we've got y equals negative x squared minus 4x plus 2? So the easiest way to graph it, let's put it in standard working form. And then let's find the zeros. Once we've done those two things, then we'll be able to graph it. So let's start with putting it in standard working form. So we've got y equals negative x squared minus 4x plus 2. So first we factor out the coefficient. So we had a negative, which means there's a negative 1 there in front of the x squared. So we factor that out, and we factor it from the x squared and from the 4x term, and then we just leave our plain number on the end here. Now we want to complete the square. 4 divided by 2 is 2, 2 squared is 4, so I'm adding 4 here. But really what I'm doing is adding a negative 4, so that means I need to add a positive 4 on the end so that I can negate that and make it go away. So then I factor, and I have this completing the square thing, which tells me my vertex is at negative 2, 6, because remember this is x minus h plus k. Make sure you pay attention to those signs. And I also know that it opens down because of this negative sign here. Now, if I find the zeros, I can use the quadratic formula, I can factor, I can use my completing the square. Well, I've already completed the square, so I might as well use that. Especially because if you look at this, if you're comfortable with factoring, you should be able to see that it won't factor. So you'd have to use the quadratic formula or just solve this completing the square. So when we solve this, we've got x plus 2 squared equals 6. So x plus 2 equals plus or minus, don't forget that, square root of 6. So x is negative 2 plus or minus the square root of 6. So what does that mean? Well, what that means is when we go to graph it, our vertex is at negative 2, 6. 1, 2, 3, 4, 5, 6. So there's our vertex. Now, negative 2 plus and minus the square root of 6. In order to graph it, you're going to need to get this in decimal form. So if you take negative 2 plus the square root of 6, you get 0.449. Negative 2 minus the square root of 6, you get negative 4.449. So 0.449 is about here. And remember, these points are zeros, so these x values, these are on the x-axis because it's where y equals 0. So there are my points, and they should be equidistant from the vertex this way, because remember it's symmetrical. And so there you have your graph. Now, sometimes you have imaginary zeros. If you have imaginary zeros, you're going to end up with a quadratic formula where you've got that b squared minus 4ac is negative. That's when you have imaginary zeros. Or when you're using completing the square and you have your x minus h squared equals negative some number. If you're trying to have something squared and you get negative, then you're going to have imaginary zeros. And so that means something like this happened. It's up here or it's down here. It means it doesn't cross the x-axis. It doesn't have any real zeros. All right, now, we also need to be able to solve these equations by the quadratic formula. So I want to go ahead and do one with the quadratic formula just to make sure. Remember, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So we just take our opposite b, so our b is negative 5, so opposite that is 5, plus or minus. Remember, we've got to have two answers. It's quadratic. You're going to have two zeros every single time. And it has to be equal to 0 for you to use this quadratic formula. So keep that in mind too. All right, b squared. Well, negative 5 squared is 25 minus 4ac. So 4 times a, which is 2, times c, which is 1. So that's 28, or 25 minus 8, all over 2a. So 2 times 2 is 4. So x equals 5 plus or minus the square root of 17 all over 4. So that's how I'll review the quadratic formula and make sure you know how to deal with those. Again, we zoomed through this. This should be review. Hopefully it is. If you're having extra trouble with it, by all means ask me questions. Make sure you've had good notes. Write questions. Take a red pen in your notes and write questions next to them so that when you come into class, you can ask those questions and know the answer, because I expect you to have questions. Make sure you ask them. You can't know if you don't ask.